So today we are introducing what we call repeated roots. And in repeated roots, I'm expecting the following. Just like if you've ever got square roots and you find that you have only two values which are the same, then we say that those are repeated roots. So in this case, if we divide a function and we get the same factors as before, we shall say we shall have got repeated roots. So we can say if a function y is equal to f of x has a repeated root, then this root is also a root to its derivative. And i.e., it is a root of the derivative of the function f of x. This week I'm going to teach trigonometry for the last time. I will not have finished it, but I have to introduce differentiation so that you have a knowledge of differentiation, which brings about these derivatives. Then also this one, if we finalize it today, then I'll have to introduce coordinate geometry next week. Yeah, so that we have a wide coverage of some of these ideas. In order to find other roots, we make use of polynomials. So in case you have a function that is describing a graph, and perhaps this graph has a curve which has a turning point here, and somewhere here we have what we call a repeated root. Then this one becomes what we call a turning point. So we shall see what a turning point implies when we look at differentiation. So, given the following equations, have repeated roots, solve them. So the first one, x cubed minus x squared minus 8x plus 12 is equal to 0. And the second one, 2x cubed minus 11x squared plus 12x plus 9 is equal to 0. The first method is the method of differentiation. I don't feel like showing you that method because we have not yet covered differentiation. Unless if you say, but teacher, you show us. Differentiation will find us there. I don't know. Okay. Before you can leave differentiation, We can first go to our first methods of using long division and factorization. So for case 1, if you investigate the factors of 12, equal to 2, 6, -2, -6, 3, 4, -3, 4, -4, and so on. So if you investigate them, when I put 2 there, you see I will have 8 minus 4 minus 16 plus 12. And definitely this is equal to 0, because you're getting 20 plus minus 20. So it means x is equal to 2. This is if I use 2. So x is equal to 2 satisfies the equation. So if it satisfies the equation, one other way you can predict that very fast is using a calculator. You know how to use a calculator? All of us. Do you have smart calculators with you?
Yes.
Yes, can you go to quadratic? As it brings up to when you arrive at degree 3. You choose degree 3 rather than degree 2. Are you there? Then put in the equation.
X1 is equal to 2.
That's what I wanted. Yeah, you can stop there. But you can also have the other roots. Now, when you use that skill, you can easily predict the value of x. So you easily confirm that x minus 2 is a factor. But give me also other values and we hear the answers you have.
X2 is equal to -3.
The third one, they're supposed to be 3. It must be either -3 or 2 again. What has it given you?
Only gives me that 2.
It means the 2 is repeated. Okay. So it means 2 is what? It's repeated. Now, if 2 is repeated, what does that mean? If it is repeated, then if you're to investigate, then it means x minus 2 and x minus 2, this is the second root. They should give me an expansion of x squared minus 4x plus 4. Now, with this, I can get other roots or another root by dividing by x squared minus 4x plus 4, and I divide the entire function. When you divide, you get x. What else do you get? X cubed minus 4x squared plus 4x. When you subtract, you realize 3x squared minus 12x plus 12. When you divide further, you realize a plus 3, you get 3x squared minus 12x plus 12. And this has divided it evenly, leaving no remainder. Hence, the remaining factor is x plus 3. So ideally, our equation was x cubed minus x squared minus 8x plus 12 is equal to 0. This is the same as x minus 2 times x minus 2 times x plus 3 is equal to 0. So we can say x is equal to 2, another 2, and negative 3. If you don't write it like that, you say x is equal to negative 3 and x is equal to 2, and then you write the word repeated. When you write the word repeated on the 2, it means the 2 has been what? Repeated as a solution. Now, the other point would be, one may need to ask, how do I know that this is a repeated root? Or 2 is the one which is repeated? I can confirm that using the what? Using the derivative method. Can you allow me to do some differentiation here, very small, eh? But if I can do it, open your eyes widely and listen to me as well. If you have a function and you're differentiating it with respect to x, this means you're differentiating with respect to x, and this function has x power n. The power you had before comes in front, which is the n, then the power reduces by 1. So if I have to differentiate x cubed, my answer will be 3x what? Squared. If I have to differentiate 4x power 5, the 5 comes and meets the 4, and I'll get 20x power 4. So the power 5 reduces by 1. So I'm just talking about it because I want to borrow it and use it here to help you get to know that how do I know that if I've investigated the 1, 2 like I did in the beginning here, how do I know that the 2 has repeated? Okay, so I have to differentiate the function. This is for checking. You differentiate the function you are given, which is x cubed minus x squared minus 8x plus 12. This will give me 3x squared minus 2x minus 8. The 12, it has no x, so you get 0 where you don't have an x. So you equate that derivative to 0. Then you can solve this derivative you've got using a calculator, but you have to show the working. So using a calculator, what do you get? You get x is 2 and x is equal to negative what? And x is equal to negative 4 out of 3. Put this in a calc and confirm those two answers. Have you substituted? Have you put in a calc? Someone confirm those two answers. I want to proceed after confirmation. Hey, wait, had we finished the other formula? I think we hadn't. I think we had. We are to introduce inverse functions. I'll discuss all the inverse functions and we stop there. Other formula, factor formula, you will study it from schools. The last definition of tree. Guys, are those the answers? People, you're quiet. Someone talk to me. Solve this with a calculator. Are these the answers we get? Mercy? Yes, since okay. People have confirmed. Now listen to me. We are just investigating to know whether 2 was exactly the repeated root, in case you didn't know. How do you confirm now? You come back to the function, this one. Substitute these values of x. The one that satisfies the equation, that gives you 0, is what confirms the repeated what? The repeated root. So can we substitute 2? When you substitute 2, what do you get? Let me use this space for substitution. You'll get 8 minus 4 minus 16 plus 12 is equal to what? 0. This confirms that x is equal to 2 has been what? Repeated. Definitely, if you use this one, it will not give you 0. Let us try it out and you see. When you substitute 3 over 4, what do you get? You'll get a negative 4 out of 3 cubed minus 16 out of 9 plus 32 out of 3 plus 12. Is it equal to 0? No way. So the one which is not equal to 0, when substituted in the function and does not satisfy the condition for the function, that one does not give a repeated what? A repeated root. Otherwise, the one which gives a repeated root is the one after differentiation. When you investigate it, the values of x you get after equating the derivative to 0, and you substitute them in the function, they will predict the repeated root. So straight away, let me use that approach for the second number so that you can become a little bit more familiar with it. Unless someone has a question on that, if I can proceed. Where has
how did
6 minus 2 come
how
from?
did negative
How did
negative 8x turn to negative 8 and 12 to 0?
Where?
Yeah. When you're checking using the other method.
The differentiation method, eh? Okay. How did the negative 8x become 8?
Yes, and 12, 0.
Okay. That's why I want to teach you differentiation, because I've seen we need it very soon. In the coming topics, it's arriving. So we need to start differentiation. So listen to me, look at me here very well. 8x, 8 is a constant. What is always affected is the x. So the x is power 1. When you differentiate the x, it will be 8 times the 1 coming forward times x reducing the power by 1. When you reduce the power by 1, this becomes 0. Any number power 0 gives you 1. That is how the 8 came about. Have I made some sense there?
Yes.
Now, how did the other 0 come about? The 0, look here very well. You're having only 12 without x. Do you agree?
Yes.
But ideally, you think outside the box, there is a silent x which is raised to power 0. Do you agree? Because the number power 0 is 1.
Yes.
So it is from that silent x we get 12. The 0 comes forward times 0. The x reduces the power by 0 minus 1. But because there is a 0 multiplying everything, everything confirms a what? A 0. That is why people cram and say, when you differentiate a constant which has no x, always you get a what? A 0. We shall see more of this in differentiation. Okay? So that's how the 0 came about, and that's how the 8 came about. I hope I've made it a little bit more clear.
Yes.
Okay. With these more examples, we are going to see we are going to become more friendly with it. So let's look at question 2. So question 2, I'm going to start with. Question 2 is an equation which says 2x cubed minus 11x to the square plus 12x plus 9 is equal to 0. So this is question 2 saying solve the equation. You can first check it and see whether it has repeated roots. And this repeated root can be checked by differentiating 2x cubed minus 11x squared plus 12x plus 9. And when you differentiate this, we shall get 6x to the square minus 22x to power 1 plus 12. And my friend who just asked me, next time we don't need to write there the 0. You can just neglect it. but you have to equate that derivative to 0. So you'll end up having 3x squared minus 11x plus 6 is equal to 0. Then we factorize. Two numbers multiplied, you get 18, added, you get negative 11. Those numbers are the what and what?
Negative 9 and negative 2.
Negative 9 and negative 2. So 3x squared minus 9x minus 2x plus 6 is 0. You will have a 3x brackets, x minus 3 bracket, a minus 2 bracket, x minus 3 close bracket is 0. So we have x minus 3 and 3x minus 2 is equal to 0. It is from here that x is 3 and x is equal to 2 out of 3. We check and see. Of course, it is only one which is always repeated, unless if the answers of x are the same. Then all the 3 power 3 means all the 3 roots are the same. But if it is having power 3 and here you're having 2 different values, then it means one of them could be repeated. Lutula, your hand is up.
Teacher? Teacher, my network was spoiled. I did not understand the depreciation method.
Okay. How I differentiate. Lutu, I said the definition for differentiation states that if you have a function and you're differentiating it with respect to x, and that function is raised to power n, the n comes forward and the x reduces the power by 1 as the solution. Whereby if I'm to differentiate, for example, x power 5, I'll get 5 of x power 5 minus 1. But 5 minus 1 is 4. So the answer becomes 5 of x power 4. Okay? And I've promised that at least if I finalize this week is trig. That is, or we can leave the inverse and start with differentiation. So I wanted to show you that we are just chipping in differentiation, the idea, because we need it here. It's not that I'm teaching it fully. I'm just bringing it because we need it. But now how to get it or how to know it is also how to deal with it. For right now, we can just have it as a definition that it is always the old power comes forward, then you reduce the old power by 1. So that is why here I reduce this old power of 3 to 2 by subtracting off 1. Then the old power 3 came forward, but in going forward, it made there a 2, which made it become a 6. Then this one was 11, x squared. The 2 came forward, made the 11 to confirm 22. Then the x was reduced by 1. Then this one had a 12. This one had the power 1. The 1 came and made the 12 to confirm a 12. The 1 was subtracted off by 1 to give us x power 0. Any number power 0 gives you 1. That is why this one gives you a constant of 12. Then the last one had a 9. But I said this 9 behaves like 9x power 0, whereby the 9 multiplies now the 0 and the x reduces the power by 0 minus 1. But because everything is multiplying by 0, that's why we ended up with a 0. Okay?
Okay, teacher. Thank you.
With these examples I'm doing, we shall be following slowly. Teacher, pardon on this differentiation. Swale. Yes, Swale. Swale, are you feeling better now? According to what I've just explained, because I think your chat came in as I was trying to explain. So let us investigate. Put 3 in this equation and we see what we get. Does it give us 0? If yes, then 3 is repeated. If not, then 3 is not repeated. Then you investigate the second one. If the second one gives us a 0, it means 2 over 3 is the one that is what? Repeated. So that is why I wanted you to get to know this technique, to investigate which exact factor is repeated. So in that sense, what we have, 2 times 27 minus 11 times 9 plus 36 plus 9 is 0. This gives me 54 minus 99 plus 25. What do we get here? I think I made a mistake. All right. This is 54 minus 99. 54 plus 25. What do you get? No. My bad. This is 45. So it gives us 0. So x is equal to 3 satisfies. Hence, x is 3 is what? Is repeated. Now, sometimes they're going to bring numbers which require proof, or they will give you unknowns to find them. Then they tell you if the function x cubed plus bx squared plus cx plus d is equal to 0 has repeated roots. Find the roots, hence find the values of a, b, and c. We shall see those numbers also ahead. So you need to have all this information in your head. So with that, it means if x is equal to 3 is repeated, then x minus 3 is a factor of the function. But also x minus 3, because it is repeated, when you multiply by itself, the product is also what? A factor of the function. Hence, x squared minus 6x plus 9 is also a what? A factor of the function. So if it is a factor, get the remaining part or the remaining factor by long division. So this is 2x cubed minus 11x squared plus 12x plus 9. This will give us 2, which is 2x. This is 2x, which is 2x cubed minus 12x plus 18x. This is 12x squared. When you subtract what we attain, shall attain x squared minus 6x plus 9. So this will give us plus 1 of x squared minus 6x plus 9. Hence the remainder is 0. Therefore, the other factor is the quotient we have got, which is 2x plus 1. So the product is 2x plus 1 plus x minus 3 times x minus 3 is equal to 0 is the factor or the factorization of that function. But because they said solve, the answer has become x is negative a half, x is 3, and x is 3 again. I told you if you don't want to write x is 3, x is 3, write x is 3 repeated. Okay? Any questions on this example before we have another one?
Is it a must for all polynomials to give repeated factors?
No. That is why we are checking. Okay? That is why we are doing what? But if the question is open and does not mention anything about repeated roots, okay? Proceed and do the normal factorization you have been doing, remainder theorem, investigate the factors, then substitute. I've already showed you in a calculator how you can investigate that very fast. But if the question has come in line of repeated roots, the questions will always state, and they will say, blah, blah, blah has factors which are repeated or has repeated roots. Find other roots. Find the roots. Yeah? Okay. Now let us do some unknowns here, which are very interesting. Otherwise, this is not so complicated according to what we have discussed so far. So to make it a little bit interesting, this is how the questions are set sometimes. They can say if x minus 1 squared is a factor. Now, you who has attended this class, you're already, if they say it's a factor, you just know x minus 1 is a factor, hence the first root is x is 1. But that root is repeated because this is squared. You see this? This is the same as x minus 3 squared. It is a factor. So if that is a factor of the polynomial, the polynomial. Which one? Function f of x is equal to ax cubed plus bx squared minus cx plus 3. And x plus 1 leaves a remainder. Now we are mixing work. These are the climaxes of remainder theorem. Of 4. Find the values of A, B, and C. Very good question. This is what I was trying to tell you, that the question is going to be set. They will not set it like just I've showed you here. What I've been showing you in the previous examples is to build the idea of repeated roots. What are you supposed to know to identify repeated roots? What are you supposed to do to handle repeated roots? So, first of all, since x minus 1, as we have seen, is a repeated factor, yeah, then both f of x and f of x prime will give 0 when x is 1. So to start with, remember the function f of x has been given as what? Ax cubed plus bx squared minus cx plus 3. Now substitute x is 1. So f of 1 should give us 0. F of 1 is equal to a plus b minus c plus 3 is 0, equation 1. For it to be a repeated root, it has to give us 1. I mean, give us what? 0. Remember what you had here. Because if you're solving such a function, it has to give you 0. So ideally, you get the first equation as a plus b minus c is equal to negative 3. This is our equation 1. Get the derivative. This means derivative. So differentiate with respect to x. We are differentiating ax cubed plus bx squared minus cx plus 3. When you differentiate them, we shall get 3a of x what? Squared plus 2b of x minus c. I think you now all know why the 3 I'm not dealing with it. It has become 0 when you differentiate. Now when you substitute, everything here has to be equal to 0. So substitute x is equal to 1. You'll get 3a plus 2b minus c is equal to 0. Okay? Now, there is another third condition which has been given. I think I can wrap this page so that I don't go there and flip the other one. Can I wrap? People took screenshots? Yeah? Let me wrap this page. So, this is what we are going to have. So we have seen so far we have equation 1, which is a plus b minus c is negative 3. Equation 2, we have got 3a plus 2b minus c is equal to 0. Now the third equation, remember the function, when you substitute a value of a root into a function, it should give you the remainder when x is 1. And the remainder when x is 1 is 0 for the factors. But now they say when the function has been divided by x is plus 2, this is our divisor, then the remainder should be when x is equal to negative 1. And that remainder has been given as 4. So substitute in the function f of negative 1. What do you get? You get negative a plus b plus C plus 3. The remainder should give us 4. So we have the third equation. So the third equation is negative A plus B plus C is equal to negative 1, equation 3. We solve simultaneously. Now you can see I can add, this was equation 2, this was equation 1. I can add Roman 1 plus Roman 3. And I also add Roman 2 plus Roman 3. When I add 1 and 3, I will vamoosh the A's. A becomes 0, plus the B's, they become 2, plus the C's, they become 0, is equal to a negative 4. Do you see that B is equal to negative 2, equation star? Then come here and add Roman 2 and Roman 3. Roman 2 and Roman 3, I'll get 2A plus 3B plus 0C's is equal to negative 1. I've already got the B, so 2A minus 6 is equal to negative 1. A is equal to 5 out of 2. Ah, my A sounds funny. Let me see. 3A plus negative A, we got 2A. 3B plus B. 2B plus B, we got 3B. Negative C plus C, we got a 0. 0 plus negative 1, you get negative 1. Our B is a negative 2. Our B is a negative 2. Ah, all my equations look fine. Can you put in the equation in simultaneous equations of 3 and check and see? I'm getting an A which is 5 of A. A, my B was wrong. My B was wrong. Why was it wrong? Let me check. We added 1 plus 3. 1 plus 3 gave me B plus B, which is 2B. Then gave me C, and C died, A and A died. Negative 3 plus negative 2 plus negative 1, we got a negative 4.
Teacher.
Yes, please.
Teacher, when you put 3 here, 4 minus 3 is equals to 1.
4 minus 3, where?
It's here. Yeah. I think.
On which equations? When I'm solving the equations, eh?
No, negative A plus B plus C plus 3 is equals to 4.
Ah, it is positive 1. Eh?
I think.
Yeah, you're right. Because the 3 crosses over. Eh? Thank you so much. Okay, with that note, when I add negative 3 plus 1, I get a negative 2. Thank you. So negative 2 divided by 2, B is negative 1. So if B is negative 1, when I add it 2 and 3, I'll get 2A plus 3B is equal to 1. So with this, we shall have 2A is equal to 4. So A is equal to 2. Correct. Now we also saw that if I have a negative 2 plus a negative 1 plus a C, I must get 1. So C becomes 1 plus 3 and C becomes 4. So A is 2, B is negative 1, C is 4. Now, sometimes the question goes further and says, hence find all the factors. We have already seen only one factor which was repeated, which is x minus 1, not so? Now, because x minus 1 was repeated, you go ahead and expand it to find the other what? Factors, and then you long divide. Okay? Let us see if it has other factors. It was not there, but I'm just giving it to you because the questions will come when you don't know how they are set. But they can set them like that, and they say, hence find other what? Other factors or other roots. Hence, other root. When you expand x minus 1 squared, what do you get? X squared minus 2x plus 1. So we are going to divide x squared minus 2x plus 1 and divide it by the entire function, which is now what? 2x cubed minus x squared and minus 4x plus 3. The first term here is 2x. Shall attain 2x cubed minus 4x squared plus 2x. Three x squared minus 6x plus 3 shall get 3x squared minus 6x plus 3. Actually, this shortens the simplification. If as long as they are repeated roots, this is very easy to bring you to the factors. So the factors are x minus 1 squared and 2x plus 3 are the factors. So though x minus 1 is repeated, so another person can write like this. As the factors. Okay. Any question? If I can bring in another example. So with these numbers, I've asked you, I sent you numbers from some question papers. I wanted to see those numbers and mark them. I also sent you numbers on linear motion. I'm sending you a lot of numbers now. Even here, I'm going to send another, I'm going to send the 1, 2, there are 7 numbers here I'm sending. And these 7 numbers, you're going to do all of them. I'm going to need them for marking. So you have up to Sunday. All those numbers, I should have marked them. Okay. So please, you submit. So let me do one more example, then I give you my assignment. Have people taken the screenshot? Okay. The next number says the following. The next number says a polynomial. A polynomial leaves a remainder. Leaves a remainder of 7 when divided by x minus 1 and a remainder of 39 when divided by x minus 2. Find the remainder when divided by x minus 1 and x minus 2. So, first of all, you let, because they want us to find the remainder, it is divided by this. You let the remainder r of x be in the form ax plus b. When a function is divided by a linear function, the remainder is a constant 7. When a function is divided, a polynomial is divided by a quadratic, the remainder is linear. Linear is in form of, you know, a line is y is equal to mx plus c. So whenever you see this part, mx plus c, this part is linear. So the remainder is linear when divided by a quadratic. You'll have to note those items down, that when a function is divided by a linear function, the remainder is a constant. That's why here it was 7 as the remainder. Here it is 39 because it is divided by a linear function. When the function is divided by a quadratic, like this one, this is now quadratic, the remainder is in linear form. So I'm letting the remainder be in linear form. Please take that note down. You can even read more about that online and even from Backhouse 1. Now, when x is 1, what is the remainder? The remainder is a plus b. And we saw this remainder was 7. So it means a plus b is equal to 7 is equation 1. Then the remainder when x is 2, they said the remainder was, this is going to be 2a plus b, and the remainder is going to be 39. Okay, then we can solve these two equations simultaneously. So Roman 2 minus Roman 1, you will get 2a minus a.
Times PD.
I'm substituting. We are substituting in this function, in this linear function. So do you see this linear function?
Yes.
Now get a value of x when x is 1. Why is x is 1? Because the divisor was said x minus 1. So you have to equate the divisor to 0 and get x is 1. If you have been doing these numbers, whatever I'm speaking, you must be following. If you have not been solving, you will not see what I'm doing. And hence we shall say that we are always fast. Anyway, let me come again. So if I get x is 1, put here x is 1. When I put here x is 1, do you see that I get a? Yes? Sorry.
Yes, yes, teacher.
Yeah. Then the b has no x, so the b remains as it is. But now that remainder
Yes.
when x is 1 was what? Was 7.
Yes.
Understand? Now for the second one, when I substitute x is 2, the remainder has to be 39. So I put x, I put 2 where there is x, I'll get 2a plus b. Okay?
Yes, teacher.
The rest I'm doing is senior 2 work, not advanced level anymore. By subtracting Roman 2 minus Roman 3. B minus B, 0. 2a minus single a, you get a. I shouldn't even have written this statement. 39 minus 7, you get 32. So a is equal to what? 32. So if a is 32, we can get b. So b is going to be equal to 7 minus 32, which gives us a negative 25. Not so. So the remainder, therefore the remainder is going to be 32 x minus 25. And that is our answer. Okay, let me note also this in words. You might not write down, students, I know you. Note, when a polynomial to degree, say for example 3, is divided by a linear function or linear divisor, the remainder is a constant. That is not 1. Not 2. When a polynomial is divided by a quadratic divisor, the remainder is what? Is a linear function. The linear function in a form of ax plus b. Here it can be any constant. It can be just a constant a. Okay. So that is another condition you have to have always in mind. We have some 13 minutes. I think they're enough for another now. Now you see in this question, they even never gave you the polynomial. We have not seen the polynomial at all, have we? We have not seen the polynomial. There's another interesting question here. Have that down. It is specifically telling you without using long division. Now, those of you who are saying, yeah, but teacher, is it a must we have to use long differentiation? May I want to go for long division? The question says without using long division. Don't bother long dividing. Find the remainder. When the polynomial, find the remainder when the polynomial x squared, x cubed minus 5x squared plus 7 is divided by x minus 1 squared. X minus 1 squared. Okay, Lutu Leida. Lutu?
Yes, teacher.
Read the question.
Without choosing one, find the remainder when the polynomial x cubed minus 5x squared plus 7 is divided by x1 minus x minus 1 squared.
X minus 1 is which kind of function? Is it linear? Is it a quadratic? Is it, what is it? X minus 1 squared is a what? Is a quadratic or is it linear? X minus 1 squared.
Linear.
Eh?
Linear function.
X minus 1 squared. Is it's a quadratic, not so?
Yes.
And it is the divisor. Do you agree?
Yes.
When it is the divisor, which is a quadratic, dividing a polynomial of degree 3, what kind of remainder do we expect? Do we expect a constant or a linear function?
Constant.
You're rushing. Think. Even they are not there. When a polynomial is divided by a quadratic divisor, what have we said? The remainder we have said is a linear what?
It's a linear function.
It's a linear function. So if the remainder is a linear function, so you let the remainder be what? Rx be in the form ax plus b. That is what we call a linear what? Linear function. Okay. Now, when x is equal to 1, we shall have, they said we find the remainder. So when x is equal to 1, we can see that if you go back to the knowledge of remainder theorem, this whole function is equal to the quotient in terms of x times the divisor plus the remainder. So in actual sense, the divisor is x minus 1 squared. The quotient, we don't know it, plus the remainder, which is in the form ax plus b. Okay? So that is how it's supposed to look like. Then it is from this knowledge that you can borrow an item here, and we say when x is 1, what would be the remainder? We shall have substitute here. Because when you substitute here, when you substitute x is 1, this one becomes 0. That is why when you substitute x is 1 in the remainder, the answer you get should be the value of the function. So you'll get 1 minus 5 plus 7 is equal to a times 1 plus b. You will get a plus b is equal to 3, equation 1. We have done this before. Now, the other second skill, because this is a repeated root, remember this is repeated. Do you remember that? Yeah? Repeated roots, we can also use the technique of what? Differentiation. Okay? Whereby, when you differentiate on both sides here, before you can differentiate, look at this. This is the same as x cubed minus 5x squared plus 7 is equal to x squared minus 2x plus 1, 2 of x plus ax plus b. When I differentiate on both sides, I'll have to get 3x squared minus 10x is equal to 2x minus 2 times the quotient, but the quotient now, you'll have it in this form. There's some further differentiation here. I never wanted to mention something about it. But anyway, let me leave this one out, this term, because it requires product rule, which you don't know. Let me just take you straight to the relation I want. Okay, you can straight away differentiate the function and differentiate the remainder. So when you differentiate the remainder, you get a plus 0. So now substitute the repeat, because I'm doing this because of the repeated root. So substitute the repeated root, which is 3 of 1 minus 10 of 1 is equal to a. Do you realize that a is actually equal to 7? So if a is 7, what is b? B is going to be equal to negative 4. So if b is negative 4, then the remainder is what? The remainder.
Teacher, is it 7 or negative 7?
Let me see. Thank you. Negative 7. So if it's negative 7, when you substitute here, b is 10. Yeah, b now becomes positive 10. So the remainder becomes negative 7x plus 10 as our answer. So the idea there was, go ahead and use the technique of differentiating, because remember at differentiation we could find, remember it is a turning point as I introduced earlier, that when you differentiate you get a turning point. So that turning point is repeated. So if it's repeated and you substitute in that value of x which is repeated, that turning point, it should give you the same remainder if when differentiated. So you differentiate both the remainder and the function. You don't only differentiate the function and you leave the remainder undifferentiated. What you do on this, the reason why I had to look at this as both sides, it's because when you differentiate both sides, you differentiate this one, you will differentiate these two, you will differentiate also this one. But when you differentiate these two, never wanted to mention, it was x minus 1 squared. You will get 2x minus 2, keeping the quotient constant. The second one is keep the x minus 1 squared as it is, then differentiate the quotient. Whereby in both cases, when you put there 1, you get a 0. That's why I forgot, I erased it. I told you I should neglect it. I never wanted to over-explain that because I may have bored you a little. When you put here x is 1, you get a 0. Even here, when you put x is 1, you get a 0. So the whole of that term died off and remained with only this one. When you put there, after differentiating, this became 0, which is 0 here. When you put here 1 at x for a, you got a. So we shall discuss this more in terms of differentiation. When you are very ready, and we land on some of these numbers, when you're very ready and well equipped with differentiation, we shall be back and do some of these numbers again. So allow me send you exercise and you take a keen look at it. And I would like to mark those 7 numbers. They are not many, but you have to go to Backhouse and solve the rest of the numbers, as many as they are. Okay. So which group? Swale, you are not on the group. Swale, which group are you asking for?
Some in new, senior 5 new.
A. That is the group. I'm sending numbers now. Okay, with that, we can have a good day. So let me send the numbers, unless someone has a screenshot they haven't taken.
Teacher, may I have a question?
Please go ahead.
Where in the first number on that board, you put the remainder as 3x minus 25. Isn't it supposed to be 32x minus 25?
Did I rub it off?
No, the first question on that page. No, go back. Not this page, that which was there. The last page.
This one, 3x minus 25. Hey, it was supposed to be, sorry.
Yes.
Thank you so much. It was supposed to be 32. You know, I'm so used to those small values in these items. 32x minus 25. Yeah, because our A was 32. Thank you so much. Because the function was in the form ax plus b. So you put the 32 where there is a, and then the x, then the 25, a negative where there is the b. Yeah, so that's how it is. Thank you. So your numbers are ready to be handled, and that has marked the end of remainder theory. Happy to announce that.
Excuse me, sir.
Yes, please.
Excuse me, sir.
Yes, please.
I would like to take a screenshot of the previous page.
Okay, there you go.
Thank you, teacher.
Welcome. You can have a very good morning.